Structures. Compilers. There are two compilers used in Go language. Those are 6G, 8G, 5G, which is developed by Ken Thompson. That is more experimental, generates object code very quickly. Not GCC linkable, but has FFI support. 6G has good Go routine support, muxes them onto threads, implements segmented stacks. 6G has a simple but effective mark and sweep collector. The other compiler is GCC Go, which is developed by Ian Taylor. That uses Go front end for GCC and generates good code not as quickly as previous one. GCC Go is lacking segmented stacks, allocates one Go routine per thread. At the moment, GCC Go has no garbage collector. The new collector is being developed for both compilers. Go offers an expressive type system, fast compilation, good performance and built-in language features that simplify threaded programming and concurrency. Google is releasing the source code under the BSD license with the hope that a community will emerge around the new programming language and participate in the effort to make it a compelling choice for software development. The native Go compilers called 6G and 8G support for 64-bit and x86 system architectures are designed to be extremely fast. There is also an alternative compiler called GCC Go that is based on the GNU compiler collection. The GCC based compiler isn't as fast but is said to generate more efficient code.
Unlike C, C++ and Java, the language Google Go ignores the semicolons at the end of the statements. It does this according to the rules. The rule number 1 is when the input is broken into tokens, a semicolon is automatically inserted into the token stream at the end of the non-blank line if the line's final token is an identifier, int, float, character, string, literal, one of the keyword like break, continue and return, one of the operator and delimiter. The rule number 2 is to allow complex statements to occupy a single line. A semicolon may be omitted before a closing braces. It is an advantage for programmer when they programming. It is obvious to forget a semicolon at the end of the statement. Other language compilers produce an error for that, but in Google Go it's okay, hence easy to write codes.
Garbage collector. One of the biggest sources of bookkeeping in systems program is memory management. We feel it's critical to eliminate that programmer overhead, and advances in garbage collection technology in the last few years gives us confidence that we can implement it with low enough overhead and no significant latency. The current implementation is a plain mark and sweep collector, but a replacement is in the works. Another point is that a large part of the difficulty of concurrent and multi-threaded programming is memory management. As objects get passed among the thread, it becomes cumbersome to guarantee they become freed safely. Automatic garbage collection makes concurrent code far easier to write. Of course, implementing garbage collection in a concurrent environment is itself a challenge, but meeting it once rather than in every program helps everyone.
No pointer arithmetic. Finally, concurrency aside, garbage collection makes interfaces simpler because they don't need to specify how memory is managed across them. Without pointer arithmetic, it is possible to create a language that can never derive an illegal address that succeeds incorrectly. Compiler and hardware technology have advanced to the point where a loop using array indices can be as efficient as a loop using pointer arithmetic. Also, the lack of pointer arithmetic can simplify the implementation of the garbage collector.
Control structures. The control structures of Go are related to those of C, but different in important ways. There is no do or while loop, only a slightly generalized for. Switch is more flexible. If and switch accept an optional initialization statement like that of for. And there are new control structures including a type switch and a multi-way communications multiplexer select. The syntax is also slightly different. Parentheses are not required and the bodies must always be brace delimited. Mandatory braces encourage writing simple if statements on multiple lines. It's good style to do so anyway, especially when the body contains a control statement such as return or break.
4. The Go for loop is similar to but not the same as C's. It unifies for and while and there is no do while. There are 3 forms, only one of which has semicolons. Short declarations make it easy to declare the index variable right in the loop. Switch. Go's switch is more general than C's. The expressions need not be constants or even integers. The cases are evaluated top to bottom until a match is found, and if the switch has no expressions it switches on true. It's therefore possible and idiomatic to write an if-else chain as a switch. Multiple return values. One of Go's unusual features is that functions and methods can return multiple values. This can be used to improve on a couple of clumsy idioms in C programs. In band error, returns, and modifying an argument. In C, a write error is signaled by a negative count with the error code secreted away in a volatile location. In Go, write can return a count and an error. Arrays. Arrays are useful when planning the detailed layout of memory and sometimes can help avoid allocation, but primarily they are a building blocks for slices, the subject of the next section. To lay the foundation for that topic, here are a few words about arrays. There are major differences between the ways arrays work in Go and C. In Go, arrays are values. Assigning one array to another copies all the elements. In particular, if you pass an array to a function, it will receive a copy of the array, not a pointer to it. The size of an array is part of its type. The value property can be useful but also expensive. If you want C-like behavior and efficiency, you can pass a pointer to the array. Slices. Slices wrap arrays to give a more general, powerful and convenient interface to sequences of data, except for items with explicit dimensions such as transformation matrices. Most arrays programming in Go is done with slices rather than simple arrays. Slices are reference types, which means that if you assign one slice to another, both refer to the same underlying array. For instance, if a function takes a slice argument, changes it makes to the elements of the slice will be visible to the caller, analogs to passing a pointer to the underlying array. A read function can therefore accept a slice argument rather than a pointer and a count. The length within the slice sets up a limit of how much data to read. Here is the signature of the read method of the file type in Packages OS.
Maps. Maps are convenient and powerful built-in data structures to associate values of different types. The key can be of any types for which the equality operator is defined, such as integers, floats, strings, pointers, and interfaces. Structs, arrays, and slices cannot be used as map keys because equality is not defined on those types.